This is honors geometry. We're going to do volume and surface area of cones. Okay, just as a reminder what a cone is, it has a circular base, of course. And a vertex that's not in the same plane as the circle. So usually the way you draw a cone, you draw yourself a little oval, you give yourself the vertex, and you draw the sides down to that. And usually you want to dash the back that you can't really see. And then of course we have a center to our base, our circle. If it's a right cone, that means that the segment joining the vertex to the base is going to be perpendicular. I'm just going to say that. So it's straight up and down. Let's go ahead and start with volume. So volume is going to be very similar to the volume of a cylinder. We still have a base of pi r squared, we still have a height, but this time because it's scaled down, if you think of a cylinder, that if this was in a cylinder, it's really 1/3 of the volume of the cylinder that would be the same height with the same base. So we're going to have to throw a 1/3 onto our formula. So the formula we're going to use for volume is 1/3 pi r squared times h. All right, to make it a little more interesting, I didn't give you all the pieces every time. Let's practice a few. So the first one, let's start here. We're given the radius, we're given the height. The height has to be perpendicular, remember, so we can see that. Again, the formula for volume is 1/3 pi r squared, which is the area of the base, times the height. And so our radius we're given is 10 millimeters, so we're going to stick that in. Our height, you can see, we know it's the height because it's straight up and down, is 13. I'm going to punch that in my calculator. What I like to do is get the answer and then divide by 3. So I'm going to say 10 squared times 13 times pi, and then I'm going to divide that by 3. It's a little less messy. You don't want to use 0.3. You're going to be off a little too far. And I'm getting 1361.35. So we're going to round to the nearest whole number. So we'll go 1361, and that's going to be cubic millimeters. All right. Now this time we didn't give you the radius of the cone, but they did tell you that you have a 60-degree angle. And you can see this is your 30, 60, 90 triangle, or maybe we want to go back and just use good old SOHCAHTOA. So I think that's what I'm going to use. So our volume formula is 1/3 pi r squared times the height, and we don't have the radius at this point. We're given the height is 22, so let's go ahead and find that radius. So from the 60-degree angle, they gave us the opposite, we're looking for adjacent. If you remember, opposite adjacent tells us we're going to use tangent. So I'm going to say tangent of 60 degrees equals opposite, which is 22, over adjacent, which is what we're looking for. I'm going to cross multiply. I'm going to divide each side by tangent of 60, so I get x by itself. So I'm going to take 22 divided by tangent of 60, and it looks like my radius is 12.7. So I'm going to go back here, I'm going to stick in 12.7, and I'm going to punch that in my calculator. So I have, whoops, that should be squared. So I have 12.7 squared times 22 times pi, and then I'm going to divide that by 3, and it tells me that my volume is about 3,715.85. So we'll say 0.9, and that's going to be cubic feet. One more I'd like to do, and that's when they give us the slant height. Be careful. That's not our height. We want, remember the height, we have to look for that right angle symbol, and they didn't give us that. But they did tell us this is called the slant height. We'll talk about that in a second when we do surface area. So from the 54, we're looking for opposite and we have hypotenuse. So it looks like we're going to have to use sine. Opposite hypotenuse tells us we use sine of 54 equals opposite over hypotenuse. I'm going to cross multiply. Sine of 54, close parenthesis, times 15. And it looks like my height is about 12.1. And just make sure your answer makes sense. I knew it was going to be less than 15 because 15 is the hypotenuse here. All right, now we do it one more time because we also need the radius. They didn't give us the radius. So from the 54, the radius is my adjacent. And I think I'm going to go ahead and use my hypotenuse again because it's given. So adjacent hypotenuse tells us we're going to use cosine. So I'm going to say cosine of 54 equals adjacent over hypotenuse. I'm going to cross multiply again. Cosine of 54, make sure you close your parenthesis, times 15. And it looks like my radius is about 8.8. All right, so now that I have my radius and I have my height, you can put it all together into the volume formula. I'm not going to spend the time to do that because we still have some work to do. All right, next up is surface area. And if you look at a cone taken apart, if you've ever had a party hat or something that fell apart, we have the base of the cone, which is a circle, so we know we're going to use pi r squared, right, to get the area of this. And then to that, we have to add this odd shape, which we actually know that odd shape is a sector. We've done area of sectors before. So just to simplify things, the formula for that is pi r L. We call L the slant height, okay? And this one they use S, but we usually call it L. All right, so let's go ahead and practice that. So I'm going to write the formula again. Surface area of this cone, we have the base, which is pi r squared. And then to that, we're going to add that odd shape that makes up the rest of the cone. And again, we use a formula called pi r L, and L stands for slant height. We don't want the actual height this time, like this. We want the slant height. So I'm going to say pi, our radius is 4 squared, plus pi, our radius is 4, and our slant height is 15. Okay, our slant height is right here. All right, this time they give us the diameter. Just be careful. We're going to cut that in half and get the radius. So again, surface area. We're going to do the bottom circle, which is pi r squared. If our diameter is 26, we know our radius is 13. And then to that, we're going to add the body of the cone, which is pi r L, pi. Our radius again, which is 13, and our slant height they were nice enough to give us, which is 20. We punched that in our calculator, we got our answer. All right, now this time, be careful, they're going to sneak these in there. This time they don't give you the slant height, they give you the actual height. So for volume, we want the height. For surface area, we need that slant height. So I'm going to write my formula. Surface area equals pi r squared plus pi r L. And so I know my radius is 5. What I don't know is L, my slant height. So I'm going to go ahead and use a quick Pythagorean theorem. A squared plus b squared. We're looking for the hypotenuse C. So I'm going to say 5 squared plus 8 squared gives me C squared. So that's 25 plus 64. So that gives me 89 equals C squared. I'm going to square root both sides. And it looks like my slant height is going to be about 9.4. Put that in my formula, and then I'd punch it in my calculator. And you know what's coming up. Let's do one backwards one before we quit for today. This time they give us the volume, they give us the height, we're missing the radius. So the first thing I like to do is write my formula. Formula for the volume of a cone. Don't forget that 1/3 because it tapers. 1/3 pi r squared h. Area of the base times the height, and then don't forget to divide it by 1/3. We know that the volume is 216 pi. That was nice of them to leave that pi there. You'll see why in just a second. We know that the height is 18. What we don't know is the radius. First thing I'm going to do, just to make our math a little easier, I'm going to get rid of those thirds. And we're officially going to divide each side by pi. I'm just going to cancel them out. Then I'm going to take 1/3 of 18. If I take 18 and divide it by 3, or times 1/3, that gives me 6. It's looking a little bit nicer now, isn't it? Now we're going to divide 216 by 6. See how close we get there? That gives us 36. Looking nice, guys. So I get r squared equals 36. We like that because it's a perfect square. We're going to square root both sides. And I get that my radius, that's a very messy r. Let's try that again. And we get our radius is 6. All right, please try the practice problems. Let me know if you have any questions. Thank you.